Hey everyone.
Hello everyone. Welcome to fine-tuning large language models with precision and speed. I am Manasa Parvatipuram. I am a solution architect at Deloitte, and I lead the AI and ML capabilities within our internal data and analytics team.
Hey everyone, I'm Sonali. I'm one of the solutions architect here at Databricks, and I'm also an AI SME. I've been with Databricks for almost 3.5 years now, and I have my background in engineering and machine learning.
Right, let's get started. Okay, a quick show of hands. How many of you here have played around with the Rubik's Cube? Right, great, fantastic. Fascinating, right? Every twist and turn of the cube repositions a bunch of other pieces. And when you go to solve, say, one side of the cube, sometimes you find that it repositions or it scrambles another side, right? So think about how you would approach solving this puzzle. Would you just randomly twist and turn, hoping to miraculously get the solution, which, by the way, I've tried that in the past? Or would you prefer a more methodical approach, a step-by-step guide that provides you with the most efficient set of steps to solving this cube? The latter, right? Fine-tuning a large language model is very similar. Every adjustment you make to the model's parameters is like that twist of the cube. Without a methodical approach, you run the risk of going in circles, making little to no progress, and in the process, racking up significant cloud costs. So in this session, we'll share Deloitte's journey with fine-tuning using Databricks and Mosaic. We'll share with you a business scenario, executive-styled financial summaries. We'll go through our version 1 and cover some scaling considerations, the version 1 architecture, some scaling considerations, and how Databricks fine-tuning was key in addressing some of these considerations. We'll then move on to version 2, do a quick show and tell. We'll share our architecture for version 2, focusing on data curation and fine-tuning, and then I'll hand it over to Sonali, who will do a deep dive into Databricks fine-tuning, best practices, and we'll double-click on some of our data curation results. All right, so let's begin with our business scenario. Now, we all know that executives want to stay informed. They want to stay on top of their business areas that they serve. They want to know what's happening in them, the latest and greatest. And in the process, they are bombarded with dense articles, reports, lengthy material. And it can be quite challenging to digest all of that information and get to the actionable insights quickly. Something like this, right? What if we could streamline this process? What if we could get to those important insights, what's truly important to these executives, and present it to them in a fashion that is easily consumable, right? Something that's simple and straightforward, like this. So we've been tasked with designing an AI solution that can sift through enormous amounts of information, get to those important insights, and present them to the executives in an easily consumable fashion. Now, we all know that large language models are experts when it comes to summarizing information. That's no secret. But the key here is not just any generic summary. What we're really looking for is a summary that is customized for that executive. It's in the language of that executive. So in other words, if I am a CFO, I want my model to speak like a CFO. So like many did, we started our journey with prompt engineering. And prompt engineering, in a nutshell, is where you carefully craft an input prompt that will guide the LLM towards a desired output. So let's take a look at our version 1, which was based on prompt engineering, just a high-level flow. The version 1 starts with our user selecting an article that he or she would like to summarize. So they might say, summarize this article for me, and they enter the article. The next step from there was to build that input prompt that added additional information around, say, the attributes of that persona, the characteristics of that persona, the tone. So I might say something like, be more professional, be more analytical, be more direct. I might also include information on what my output should look like. So for example, I might say, give me an executive summary. Give me some key takeaways that are relevant for that persona. Give me some key action items that I need to take from this article. So all of this information in the form of a long, complex, multi-step prompt gets appended to the article, gets sent to the LLM. The LLM now looks at your instructions, understands the nuances, understands what needs to be done, and then it constructs the output response. Great. So now we have our output response. What's next? The next thing we needed to do was take the solution and scale it from tens of users to tens and thousands of users, or even hundreds and thousands of users, depending on your use case, right, across your organization. And that is when we had to consider multiple scaling considerations, like take into account multiple scaling considerations. So let's take a look at some of them. Okay, top of the list is response times. No surprise there. We all want our applications to run fast and return results within seconds. Right? But often when you have long and complex prompts, that translates to longer response times. Long and complex prompts also translate to greater token usage, and as a result, higher cloud cost. When you have long response times and higher cloud costs, then you can only do so much customization. It really limits what you can do with the application. And in our case, we want to be able to expand the solution to more than just, say, one persona. We want to maybe extend it to multiple C-suite level personas. Maybe we may also want to extend it out to business leaders across business lines and business areas. So you can imagine how quickly the prompt can get really long and really complex. The second set of considerations starts with output reliability. Again, extremely important. And we just didn't want our output to be reliable and accurate. We want it to be consistently reliable and accurate. Like it needs to show that accuracy with every incoming prompt. We want to reduce bias in our output. We want to minimize or even eliminate hallucinations. And that means we need to have some level of control over our training data set. And last but not the least, data confidentiality. We want to be able to use our application with sensitive data. We want to use it with proprietary data, with confidential data safely. So taking all of these scaling considerations into account, we decided to explore fine-tuning. So fine-tuning is where you have a pre-trained model, so a model that has already been trained on a corpus of data, and you adapt it to a specific scenario or a specific data domain. And in our case, that was executive-styled financial summaries. Okay, so let's take a quick look at what the flow for version 2 looks like. Now, version 2 starts very similar to version 1, where you have your user coming in and selecting the article that needs to be summarized. But now, instead of appending a long, complex, multi-step prompt, we send the article with a simple prompt, something like summarize this article for me, to a fine-tuned LLM. And in our case, that was Mistral 7B. The LLM is already tuned and it knows the characteristics of my persona. It knows what the tone is like, what are the attributes like, what do they care about. It knows what the output should look like. I need to have an executive summary. I need to have some key takeaways that are relevant for that particular persona. Right? And within seconds, I have an output response that is customized for the user. So let's take a quick look at the demo before we dive into the results. Let me make sure this plays. All right, so we built a very quick UI using Streamlit with just a few lines of code in order to interact with our model. But in a more professional setting, of course, you'll have a web UI that has all the bells and whistles. So you can see here that we entered an article and it's running. And in less than 5 seconds, I have an output that has a nice overview for that person. In our case, that was a CFO. I have some key takeaways from that article that are relevant for the CFO. And then I also have some key action items that they can quickly look into and take action on. 5 seconds. And the article that I pasted up there was about, I want to say, 8,500 to 9,000 words. So you can see that I didn't have to prompt the LLM to say, give it to me in this way, this is how you need to sound, this is what the output should look like. None of it. My fine-tuned model already knows what this persona needs. And again, depending on, right, you could expand this to multiple personas, pick the persona and it knows what it needs to provide. So the next, I went ahead and ran this for a second article, and there's a point I want to make here. Again, same thing, right? I ran for a second article, and you can see it again summarized. It provided me with like an overview, key takeaways. But now you'll see that the action items here say no action items. This is important because it's very easy for an LLM, or I would say that it's risky when you prompt an LLM to provide the output in a certain format. If you say, give me key action items, it is going to try and give you key action items even if there aren't any. So that's your risk for hallucination, right? You have to add additional information to say, if there are no key action items, don't bring in any. And even in that scenario, it's not really consistent. So we made sure that when we tuned this model, that we had input samples, the prompt response pairs, where the model was tuned to look for, are there any key action items? If there are none, then I'm not putting in any. Okay, so let's take a quick look at the results here, and we'll be doing a deep dive of the results here in just a few slides. But let me start by saying, in the entire fine-tuning exercise, the most important part is your data and the quality of your data. It all starts with your data. So in our case, we had 3 golden summaries. Our business was able to provide us with, when we started this exercise, was able to provide us with 3 summaries for 3 different articles that was generated by a human, right? That was prepared by a human, great. But 3 articles are nowhere near enough to fine-tune a model, right? We need in the order of thousands to be able to fine-tune successfully. So we decided to augment our training data set with synthetic data, because it's not practical unless it's already available to go back to the business and say, I need 5,000 samples. So have someone sit down and write 5,000 samples for me, right? It's a very tedious task. So we used Llama 3 in this case to generate synthetic data sets using those 3 golden samples as an example. And we used DBRX as the judge to judge the output quality. We also engaged with our business, so they did take a look at the output and they provided us with some feedback, and we went through some iterations there, tweaked the prompts, and finally we had 5,000 high-quality prompt response pairs. Prompt being the article, response being a summary in the voice of a CFO. The next step from here was to train the model. In our case, we picked 3 models, MPT-7B, Mistral 7B, and DBRX. We started with a model with fewer parameters, right, comparatively, a 7 billion parameter model, because we wanted to see how far can we get with the smaller model first? Is it going to give us results that are decent and comparable to what we were seeing with some of our prompt tuning results, right? And if not, then we were going to go to a higher parameter model. But even just with the initial test that we ran, and it took 20 minutes to fine-tune, say, MPT-7B, we used about 4,500 samples to train the model, or fine-tune the model, I should say, and reserved 500 samples to evaluate the results. And at that point, we had 10 more golden samples we were able to receive from our business, so we included that in the sample too, the evaluation set as well. And we could already see some pretty decent results with MPT-7B. So we continued this process. We used GPT-4 as our judge, LLM as a judge, for the fine-tuned model. We had our business again engaged with us to provide feedback on what the output results looked like. But in summary, we were able to fine-tune 3 different models in a matter of minutes, I would say. Anywhere between 20 to 40 minutes is what we were looking at, and get some very decent results. And the demo that you all looked at a few minutes ago was from the Mistral 7B. I want to quickly talk about some of the performance metrics that we measured these models against. So we looked across 3 metrics here. One was answer similarity, which is where we are looking at the output from the fine-tuned model and compared it with the golden summary that we received from the business. And we wanted to see, how does it compare? Is it in the same structure? Is it in the same tone? Does it have the same attributes, right? So that was the answer similarity. Then we looked at the answer correctness. This is where we are comparing, we are looking for factual accuracy. So for example, if we have statistics or numbers in our original article, we wanted to make sure that the summarized article also had the same numbers and the same facts and everything. Nothing changed in the summary. And finally, the answer relevance, which is where, again, we are comparing the output to the input article to see how relevant is my summary to the input article. Is it the same? Did it hallucinate, or what did that look like? And you'll see here, I think the key takeaway here is that across these models, the performance metrics were very comparable. And we are looking at, especially for our baseline, we're looking at a trillion parameter large language model, comparing it to just a fraction, right? 7 billion parameter model. And this is just one iteration of what we did with fine-tuning. So the more golden samples we have from our business, the more data that we are able to use for fine-tuning, the results can only get better. So in summary, for this particular use case, we were able to leverage Databricks fine-tuning to solve, or help solve, for our Rubik's Cube, which is executive-styled financial summary. So with that, I'll hand it over to Sonali to deep dive into Databricks fine-tuning.
Perfect, thank you. All right, so before we move on and talk about the solution side, let's take a step back and talk a little bit about fine-tuning. So as Manasa mentioned, with fine-tuning, you bring a pre-trained model, you bring your specific data set, then you train that model with that data set so that it does something really specific. But what actually happens under the hood? So all these large language models, transformer models, at the end of the day are deep neural networks, right? So basically, these are machine learning algorithms. Machine learning algorithms are based on mathematical equations. So little bit of blast from the past, y equals to alpha x plus beta, where alpha and beta are the weights and bias respectively, and altogether they are the parameters. So when you fine-tune a model, you do not start from the scratch. You adjust these parameters based on the new data that you see. If you guys have heard of GOAT, that's basically good at arithmetic model that was released. That was a fine-tuned model, and it was really good at arithmetic problems and solving those problems, right? So when you're adjusting these parameters, you can either choose to adjust one layer, 2 layers, 3 layers. That is just the subset of these parameters. That's called parameter efficient fine-tuning. But you can also choose to adjust all the parameters across all the layers. That's full fine-tuning. Research shows that full fine-tuning gives you very better and more accurate results, but it does need a lot of resources. So those are the differences. One of the questions that you would immediately think of is like, hey, why didn't you train from the scratch? It has a very naive and very straightforward answer. You need a lot of data, and I'm talking about trillion worth of tokens. That's a lot of data. You need higher specialization, time, and also expensive GPUs, and we all can agree that's a bit of a problem. So there you go. So let's now look at the use cases that you can solve with fine-tuning. The first one is going to be continued pre-training. So all these open source models that you have in the market, they have been trained up to a certain amount of period of time. They have a cutoff date. What about the new information? What if you want to train it on some of your proprietary data sets? You want to factually change what the large language model knows and understands. That's the continued pre-training. A more simpler side of fine-tuning is instruction-based fine-tuning, when you're not trying to change or impart new knowledge to your model, but you're just trying to change the response style. So this is what we did for Deloitte's use case. We essentially wanted to create an LLM that speaks like a CXO. We didn't want to change what it understood, but we wanted to change the response styles. So fine-tuning is amazing, but that doesn't mean that you should start fine-tuning for every single use case. There are certain considerations that you need to keep in mind so that you can qualify a use case. first of all, and this was very important for Deloitte, right? So if you want data privacy, like that's a big concern for you. You want full ownership on your data. You want to control what the model does, what data it uses, so on and so forth. But make sure that you do try some few short learnings and some prompt engineering to see how the model behaves. How much can you regulate its behavior? So if you see decent results and you're not happy with it and you want to get more accurate results, fine-tuning is going to be a superhero. There would also be instances where you have very strict latency requirements or you have cost restrictions. In that case, maybe a smaller, lightweight, simple, fine-tuned model can give you more and better and faster results with a fraction of a cost for your very specific task. Now, fine-tuning is a great tool to have in a toolbox, but it does have its challenges. So these are a few of them. Let's start with the data. So if you're trying to do and solve for a supervised problem, you need labeled data set. Manas already mentioned that is going to be the most important thing. So, but the data is hard to come by. We all can agree on that. But once you have it, you can't just like simply start fine-tuning it right away. You need to pre-process it. You want to make sure that the model understands that data. So you would have to run some engineering pipelines in order to make sure that the model understands what you are throwing at it. Then you also have like operational side of the things. Open source libraries are amazing. Databricks is a big supporter of open source community and we contribute quite a bit. But when it comes to fine-tuning, these open source libraries require you to do a lot of hard work. You need to understand the model architecture of the model that you're going to fine-tune on. And there are a lot of bells and whistles. You have to answer very important and hard questions like, what should my batch size be? Should I be using this regularization technique? Do I need to optimize? All these questions are very, very hard. And what if like your model fails in between? What do? Do you start from the scratch? But these things are very expensive to run, right? So you need to understand, hey, how can I manually checkpoint my model training process so that I don't have to start from the scratch? And also like, there's another point that you can't see, but that basically says that it's part of a problem, of a bigger problem, and the bigger problem is machine learning stack. You need to make sure that your fine-tuning pipeline fits very nicely with your ingestion and your model serving. That's in itself is a different rubrics cube that you need to solve for. But it doesn't end here. In terms of fine-tuning, the major heavy lifting is done at an infrastructure level. So think of all the complex networking configurations you need to set. There are a lot of low-level infrastructure settings that you need to set. So for example, in most of the cases, you'll end up doing multi-node GPU-based training. How do these nodes communicate with each other? How you want to kind of distribute your model. That's called model sharding. Extremely crucial. Should you be throwing one model per node or pieces of a model? These are some very hard questions to answer. Then we will have our good old friend out of memory errors. No one likes to see them, but you will see them, right? So you have to kind of solve for all these problems. Out of memory, node failures, so on and so forth. The list is endless. So now let's see like how Databricks help solving these challenges. To start with data, as Manasa pointed out, when we first started, we had three samples. And we are talking about fine-tuning billion parameters worth of data. 3 samples will not even like make a dent. So one of the important tasks that we had in our hand was how can we prepare a fine-tuning data set? This was a very creative problem with a very creative solution that we came up with. The answers was GenAI. So we generated our training data set. So first of all, what we did was we did a tone analysis on all the articles we were seeing, as well as all the summaries that we had to kind of figure out like what are the characteristics we are looking for. Once we had those characteristics, we crafted a prompt and we generated the summaries. We used Llama 370B to do this. Once we had this, then the important question was like, is it a good enough data set? How do I know it's a good enough data set? That means we needed to have an evaluation framework to verify if the data set that we were creating is good enough. Because again, these GPUs are a little expensive, right? So we had an evaluation framework. We used LLM as a judge, and we used DBRX as the judge. And then we also had the business give us feedback. Hey, do these summaries make sense to you? And ask targeted questions from your business. Help them a little bit. What was missing? Do you want more stats? So on and so forth. But this was not a singular flow. We iterated and iterated and iterated, 32 times to be exact. And at the end of these iterations, we ended up with a really good training data set. And then what we did, we fine-tuned it. And we used Databricks Mosaic AI fine-tuning for this. So Mosaic AI fine-tuning is essentially a very simple API that you get with minimum configurations needed. So forget about those knobs and whistles that I mentioned, right? No batch sizes, nothing. Very minimum configuration so that you can fine-tune AI models, not just large language models, but other models as well, in a very secure, scalable, and cost-effective way. The Mosaic AI fine-tuning sits very nicely in our unified platform. That means you do not have to stitch a bunch of things together for it to work. It just works. And very important for our customers and Deloitte was the governance side of the world. So the good thing is, like, we provide a governance solution out of the box, and you can govern not just your training data set, your models, but even the end results. So now let's try to look at how you can evaluate the fine-tuning models. This is going to be very, very important. And we came up with a very robust threefold strategy around this. We had intrinsic evaluation. So intrinsic metrics are the metrics that you collect when you are actually running these model runs. So these are the model. So if you come from traditional machine learning background, think of like F1 score, accuracy, so on and so forth. We also used LLM as a judge again. So MLflow provides quite a bit of those, and we'll go through these in just a second. And finally, the human feedback. Now let's do a little deep dive into each of these. All right. So we picked two main metrics. One was the token accuracy, which essentially measures how accurately the LLM is able to predict the next token. And the second one was perplexity, how confused or how low of a confidence the LLM had when it was making these predictions. For a really good model, you need high token accuracy, but low perplexity, not the other way around. Otherwise, we'll be in deep trouble. We used LLM as a judge, and we used MLflow framework to achieve that. MLflow provides a lot of different metrics. These are just three that we used, but there are many more that you can see on the documentation. But what we were really looking for was a way to figure out if my generated summaries, if my predictions are very close to the article, factually correct with the article, but also like the business summaries. So you want those to be factually relevant, but also correct, right? They should be semantically similar. And human feedback. So again, like, we wanted to make sure that the human feedback was in the loop so that we have the contextual understanding when we are evaluating our results. Make sure that you have a very robust evaluation framework. Now let's put it all together. There are like quite a lot of pieces that we talked about. So the first one is the data generation pipeline. We had two data sets. We had the data set from Deloitte, and we also wanted to include more line items. So we had around 2,500 from one side and 2,500 from the other data set. We threw it in the data generation pipeline. We got the summaries. We wrote it to Unity Catalog. And Unity Catalog also has something called as model registry. So essentially, all the models that you use, you can easily govern them directly from Unity Catalog. So one place to govern it all. Then we took the training data set and evaluation training data set. We fetched the model from the Unity Catalog. We sent it to the Mosaic so that we can run multiple iterations of it. This is where we also did a lot of hyperparameter tuning, called as, the word is hyperparameter sweep. This is important. So what we were doing at the time was like we were recording every single run back to the MLflow. It was really important because we needed to overlay an LLM judge framework so that we can evaluate it as a whole. So we were recording every single experiment and comparing the results, making the changes, and then iterating again. We did 12 such runs. Once we were happy with the results, we logged the final model back to the Unity catalog so that, again, governance, so that we can govern it. And finally, we exposed the end result as a model endpoint and open it up for the users to use. All right, I quickly want to show you what was the impact that the fine-tuning model brought. You already saw in the demo, and I cannot fit the prompt, so I just have the results. But we threw in the input, and this was the prompt engineering output. Some of the key things that kind of stands out. It is really hard to follow. It's like a lot of text. Humans have very little patience. I certainly do. It also missing a lot of stats. It was not able to capture a lot of the statistical information, the numerical information. Inconsistent response was a huge problem. We couldn't get a consistent response because the output that we were getting was prompt engineered, right? And this is the fine-tuning output. Pretty neat. It adapted Deloitte style. It was able to kind of show those characteristics that we fine-tuned it for. Digestible bullets, I love that, personally. And also the clear action items. And again, I want to reiterate one of the important requirements that we had from the business was only show the action items when they exist. When they do not exist, do not show them. This was very important for us. So some of the benefits that we got from doing the fine-tuning and doing it on Databricks fine-tuning was, number one, was ease of use. Once we had our training data set, we just wrote those 4 lines of code and kicked off our run. It was less than 15 minutes that we had the first response, and we had saved our first fine-tuned model. Databricks handles all the infrastructure side of the world. So you didn't have to manage we didn't have to manage the scalability aspect. If we had a failed run, it had an automatic checkpoint, so we didn't have to start from the scratch. So we saved a bunch of time, we saved a bunch of money. We completely abstract the infrastructure level settings. So we didn't have to pick model sharding, like do I do hybrid sharding? How do I distribute my model? Nothing like that. It's also fully integrated with the rest of the stack, as I already pointed out. So we were able to ingest the data and model and serve the data just from the same platform. And finally, governance. We were able to provide full control on our data and model. This was very, very important for Deloitte. We used other features such as lakehouse monitoring, and automatic inference to make sure that we are logging every single request. This is also important from the standpoint of measuring for toxicity and bias in our model. A lot of regulations around AI. And finally, we did put a strategy together following what we called as Databricks AI security framework, which gives you a very opinionated view around how you should be thinking about governing AI solutions. To end, there are certain best practices that we want to share with you that we learned over the course of our project. The first one is around data. Cannot emphasize enough. It's still a machine learning problem. Garbage in, garbage out still holds good. Remember that a high quality data would trump high quantity data. But if you have more data, use it, right? Follow the machine learning data best practices. So for example, like duplicate entries, how to tackle the dirty data. Make sure that you follow, those still apply, so follow them. Pay attention to the data format that your model is expecting. And finally, one of the major learning from our side was we had 2 different data sources. So what we did, what worked really well for us was take a subset one-on-one from these 2 different data sources, put them together, run various like parameter sweeping, and then once we were happy with the results, then we upscaled it. This helped us because it was less data to begin with. Our iterations were much faster, and we were able to run a wide variety of hyperparameter sweep. Make sure that you try bunch of learning rates and bunch of training duration. As I mentioned before, the API that we provide to you has minimum configuration. These two are the most important hyperparameters that you would tune. These are the learning rates that you see on the screen are the ones that we tried for. It worked for our use case. These are really good starting learning rates, but depending on your use case and depending on the model you pick for, you might have to try some more. And evaluation framework, very important. It's not a traditional machine learning problem, so intrinsic metrics are not going to be enough. Make sure that you have a very robust evaluation framework so that you're not lost in the dark. You should also explore custom metrics, especially if you're trying to do something very specific. Make sure that you have specific metrics to evaluate. And finally, iterate and iterate and iterate. And record those experiments, record those iterations. This is going to be your best friend and your guiding star. Nothing else would work. The only way to be sure that if something would work is by working it. I hope today's talk was helpful. You learned about fine-tuning. If you want to try it yourself, this is a QR code. If you scan this, it would take you a demo page. Thank you very much.